All right, well, so we have this problem here from section 1 of chapter 2. And what we're going to do is we're going to use our difference equation to find the slope at the point 4 comma 1/2 of this function and the tangent line, the equation for the tangent line. I'm going to rewrite this in terms of f of x equals 2 over x, and so we'll want to use our difference quotient. I'm going to start using this notation because we'll define it very shortly, that this is going to be the derivative of x, and I'm going to introduce the notation that we'll see in section 2, that we want to look at what happens as h goes to 0 of f of x plus h minus f of x all over h. So here's the difference quotient we had, and what we want to do is we want to replace h with 0. So this becomes the format that we're going to see here. So we will substitute 2 over x plus h minus 2 over x all over h. And I'm going to just focus on this part here, knowing that when we're done we'll have h go to 0. Now, because we have a compound fraction, what we'd like to do is to get the same denominator, and then we can play with how this looks. So what we'll do is, we notice this has x, and this has x plus h. So what we want to do is we want to multiply this side by x over x. So we get 2x minus 2 times x plus h over x times x plus h. Right, because this side needs, let me put this in a different color here. This needs x over x, and this needs x plus h over x plus h to get a common denominator. And this whole thing is over h. And so we're going to do a little bit of cleanup here. So if I look at the numerator, I'll bring it up here. We have 2x minus 2x minus 2h over x squared plus xh times 1 over h. If we do a little cleanup here, the 2x's cancel and I get negative 2h over x squared plus xh times 1 over h. These h's cancel each other, and I get negative 2 over x squared plus xh. Now we can take this, we can have h go to 0, because we'll no longer have the problem in the denominator. And so as h goes to 0, we get negative 2 over x squared. And so this is, again, I'm going to introduce this notation as the derivative, but this is our slope anywhere on the function. And so we asked for what the slope would be when this was 4. So we get negative 2 over 4 squared, or negative 2 over 16, or negative 1/8. So now that we have the slope, we can work on our tangent line, right? 4 comma 1/2. So the tangent line will be y minus y1, so that's 1/2, equals negative 1/8 times x minus 4. We'll push the 1/8 through, so we'll get negative 1/8 x plus 1/2, and then y equals negative 1/8 x plus 1/4, and we have our tangent line.